All right. So welcome to Engineering Structural Analysis. Our first lecture is going to be talking about what a structure is, the components that comprise it, and how we are going to begin analyzing or modeling a structure. I always like to start out all of my lessons with the learning outcomes so that you can know what to expect and what I expect you to know when it comes down to exams. So by the end of this lecture, you should be able to identify structural elements, components, and systems, classify a joint or support and determine its associated constraints and reactions, and draw an idealized model of a structure. So what is a structure? Let's do our most basic thing and go say Webster's Dictionary defines, right? What is a structure? It is something oops, let's not use the word comprised. It is something comprised of elements or components arranged in a system for a specific purpose. Normally, when we think of a structure, we think of a building, right? Which is made up of walls and floors and beams and columns, specifically to house people or to provide shelter, I guess would be the more technically sounding thing, right? We also, another traditional structure for civil engineering is a bridge. Again, we have our bridge deck, we have our piers, we have our abutments, whatever is holding up the bridge deck, if it's trusses or cables, and it provides a purpose for allowing traffic to cross roads and waterways. But you could also think of a structure as basically smaller things like sand. I did my dissertation on granular assemblies, so like there we have sand providing support for, or soil providing support for foundations and the like. You also can have like a table would be a structure, right? Just looking around my office, right? We got a table. It's comprised of a top and some legs, and its purpose is for making things so I don't have to sit on the ground. I can sit in a chair, right? So all kinds of things are structures. Obviously, we're sticking more to civil engineering structures for the most part. So let's talk about some individual structural elements. I'm going to start out with linear, one-dimensional elements. Linear meaning its primary dimension is one direction, right? Like a beam or a column, or right? It's all mostly in one direction. And such elements would be braces, tie rods, cables, wires, struts, columns, and beams. I'm going to show some pictures of some of those in a minute on the next slide. Right, starting in the top left, we have some steel beams. Actually, those are just steel sections, but they're horizontal, so we'll call them beams. Turn them up on their ends, they're columns, right? Here, next we have some cables. You often see those, you know, cable stay structures like bridges, or this even looks like it could be, you know, part of a fence. Now here we have tie rods. These are helping to hold up the roof, or the supporting structure for a roof. Again, everything's in one dimension. We have some concrete columns down at the bottom left. Right, we've got some concrete with some rebar sticking out of them. Here we have some concrete beams or girders holding up my bridge deck, right? Next to that, we got some braces here, and I guess a column technically in the middle. And here's another column, right? It's probably steel structures, look like maybe hollow steel structures or a steel column. Right. Diagonal steel braces are often used for lateral resisting systems of structural steel buildings. Talk about that more in steel class, but that's where you see those, right? So these are all examples of linear elements, right? One dimension, the major dimension is only in one direction. The other two dimensions are very small compared to the length or the height, if you're talking about columns. Next, we have structural elements that are two-dimensional, meaning two of its dimensions are pretty large compared to a third dimension. That's pretty small, right? We're thinking about a floor or a slab, maybe even a wall. Right, looks mostly like a surface. And examples of that would be a floor, a slab, a wall, or a membrane, something very, very thin. So if we're looking for those, right, top left, we have a membrane over here, providing the roof structure for this bus station. Below that we have a metal deck or roof, right? Some corrugated metal there. Next to that we have our concrete slab. This looks like the foundation for somebody's house. Next to that, we have a concrete floor. Right, again, here's our concrete floor. Up above it, we have a bridge deck, probably made out of concrete. Maybe, oh, yeah. So those are some horizontal surface members. Some vertical ones, right? We have a wall here, foundation wall, retaining wall. You could also obviously have a wall of an actual building, like a shear wall. Don't have any examples on the page, but you know, walls don't always have to be associated with dirt. But those are some example of surface structural elements, right? Again, 2 dimensions. You know, the third dimension is much thinner compared to the other 2. I'm not talking about any 3-dimensional structures because generally we break stuff down into 1 and 2-dimensional elements. 3D would basically be a big blob, right? A big block of something, and that's generally, I mean, why are you designing a structure that's a big concrete cube? That's a lot of concrete. Probably don't need all of that. But that would be mostly when you're talking about modeling structures like that. You're talking about like the sand particles I talked about, individual sand particle, or some sort of other mechanical components are typically modeled with 3D elements, but we're not going to get into those in structural analysis. So now that I have my individual pieces, I can put them together in individual structural systems, put together things into a truss or arches, cables, cable systems, right? Frames, surface structures, and generally all of these systems work. There are multiple systems within an individual structure, right? If you just had a bunch of cables, you might not be holding up a bridge. Got to have your surface there too, right? So here we have our truss. A typical, roof truss holding up the roof of a building. Kind of a long truss right here. Holding a cell tower, go those cables. There are actually probably some cables holding it up too, right? Let's see. Right, we have our truss that the truss itself is acting like a whole column, and then some cables are helping hold it in place. Next to that, we have a truss for a building, a bridge. This is the walking bridge right next to the presidential library. We have some trusses here at the Dallas Stadium, AT&T Stadium in Dallas, holding up the retractable roof. And finally, we have a little truss holding up our bridge deck so that Joe can go get milk at the store. Right? Again, all of these, like, see the deck, you have the surface element of the deck, but the truss is the main support system holding up that deck. Our next structural system that we can talk about is an arch, right? These lovely stone arches. Think of like the aqueducts or in ancient Rome. A lovely arch bridge holding up the bridges here. Very pretty, you know. There's some really pretty arch bridges, like, what is it, over the New River in West Virginia. They're fun to look at. Next we have some cable systems. Right, here we have some cables holding up the roof of this arena. You often see cables in suspension bridges, right? Here we have cables holding up this bridge deck. These cables holding up the Golden Gate Bridge. And these cables helping support the deck of the Roebling Bridge in Cincinnati. Right, we also have in here, like, right, you can see there's some trusses. There's some trusses holding up my bridge deck. So it's always multiple systems, right? Not always, but often multiple systems. If you didn't know, I'm from Cincinnati, which is why I know this, but the Roebling Bridge in Cincinnati was the prototype for the Brooklyn Bridge. Roebling built it in Cincinnati first, just to test it out. So it's a really neat bridge to drive across. I get all, you know, structural engineering nerdy whenever I get to drive across it back in Cincinnati. So our next structural system here, we have some steel frames. Right. Got some columns and some beams and some braces, all making up the steel frame building, right? Column, beam, brace. Here are some roof beams, roof girders, beams. And again, we'll still have obviously some sort of surface, or else you'd fall through the floor. But the general system of the building is a steel frame building. Structural steel. And finally, we have some surface structures. These are often lightweight, providing shelter, not necessarily, I don't know if you would walk on them, right? We have an arena with the surface, probably being held down by some cables. Another truss supporting a surface roof. This is a lovely roof of the Natural History Museum in London. And some other surfaces, right? Here we have the Opera House in Sydney. So those are just some example structural systems. I'm going to pause here and start another video on how we idealize modeling structures.